Good evening, I am Mr. S. You are joining me for what will be a very interesting video and a useful video because we're going to examine two standardized test style geometry problems. These are the types you will actually see on some of those standardized tests we are all familiar with. Here, question number one, we have a representation here made up of four circles which are all tangent to one another. And from the centers of each circle, we've connected these lines to generate a square. The question is this: we know that the area of this square right over here is 8. We have to find the area of a circle. Any of these individual circles, what would the area for the circle be? Each of the four circles has the same area. We're only interested in the area of a single circle. How can we go about doing this? Well, if you pluck out that square, you know the area is 8 and each square has similar sides. And the two sides multiply to give you the area. X squared is equal to 8 and x is equal to root 8, which is 2 root 2. You can just do the radical 8 and you can pluck out a 2 because root 8 is a 4 times 2 and you get a 2 root 2. When we are looking at this 2 root 2, we have suddenly determined the side of this 2 root 2 and we've also determined the side of that 2 root 2. Now if you focus in on these circles, you see each of these represents a radius. You got these radius going on. We have 2 root 2 representing the side of this, which is made up of 2 radii of 2 circles. If you were to take this 2 root 2 and divide it by 2, you'll get root 2, which will represent the radius of a single circle. And you can see that radius of a single circle is root 2. Just from right here to right here, you've taken 2 root 2 and divided by 2. Because 2 of these radii are generating this, a single radius must be 2 root 2 divided by that 2 and you get a root 2. Therefore, the area of a circle is pi r square, and you're doing pi root 2 square. You square the root 2, and you know that's not hard. You'll get it 2 pi, and that right here is the answer of a circle area. So this right here is a typical standard presentation of a geometry word problem or a geometry graphic problem. And it's an interesting type of question because it involves a variety of techniques to get to the answer. Now this question number 2 is designed similar to the one you've just seen but slightly different. As you can see, we have 3 circles here drawn in a triangular format within which from the centers of these circles we've generated a triangle. If each of these circles has an area 4 pi, we have to determine the area of this triangle. How can we do that? Start with what you know, which is 4 pi. We know 4 pi represents the area of one of those circles and the formula for an area is pi r square. You can actually calculate the radius. The pi's cancel out. Radius is equal to root of 4, which is 2. When we look at that, we know now each of these radii or each of this radius is 2 and you can mark them all. You don't need to mark them all, but I'm just marking them for the purposes of this video. We've generated 2's all around. When we pluck out this triangle, now we have generated a side, each side being 4, because 2 plus 2 is 4 and you have 4 all the way around. We have an equilateral triangle. You know we have to find the area of a triangle for which you have to have half, base and height. We do have a base, but we need to generate a height. If you draw a perpendicular bisector over here and you know it's at 90 degrees, you can split the 4 into 2 parts, each of these being 2 and 2. You can just focus in on this triangle and show it here again. You're looking at a 2, a 4 and a right triangle. You're going to fight the Gorian Theorem. A square plus b square is equal to c square. We're calculating for this height. So you have 2 square plus h square is equal to 4 square. You have 4 plus h square is equal to 16. H square is equal to 12. And h is equal to root of 12, which will be 2 root 3. So we've gotten our height. We know our base. Our base right here is the combination of these two, which is a 4. So we have everything we need now to finish this problem. So the area of this triangle will come down over here as a half times base, which is this 4. The combination of 2 radii gives you your 4 and the height 2 root 3. The 2 2's can cancel out. You have a 4 root 3. And that will represent the area of the triangle 4 root 3, and it would be a good answer and you would be done. And with that we end this video. So keep these type of questions in mind. They're too common and they're too frequent on these standardized tests, and you know what those tests are. Thank you for watching. Have a nice day.